I'm Don Hillman, a retired professor from Michigan State University. During my retirement, I have assisted farmers in over 100 stray voltage cases and have studied electricity extensively. Electricity is a blessing to mankind when carefully managed and when its effects on the body are understood and respected. But like alcohol, drugs, and tobacco, when electricity is not properly controlled or people are overexposed, electricity can cause human and animal health problems. In 2003 and 2004, I discovered uncontrolled electricity, so-called electrical pollution, in homes, schools, and workplaces in East Lansing and other places in Michigan. The objectives of my presentation are educational. I will define electrical pollution and identify known causes and sources, explain known hazards of electric pollution, show how electrical pollution affects electrical equipment and health of people and animals, identify ways to monitor electrical pollution in your home and community, and show you ways to protect yourself and your family from electrical pollution. Much information about the effect of electrical pollution is available in books, hundreds of articles in scientific journals, and on the internet. Yet very little is reported in the news and nothing is taught in schools. We are 20 years behind our counterparts in Asia and Europe in understanding the harmful effects of electricity, electric and magnetic fields in the living environment. Because research in universities depends on grants, the money is spent on developing new electrical devices and medical treatment, and very little on prevention of electrical effects on human and animal health. To help you understand the remainder of this presentation, I will first explain a few key electrical terms. A conductor is an object or a substance that provides a path for electric current to flow. Conductors shown are the overhead lines, the air, the earth, the metal fence wire, and the man. Voltage is a measurement of the electrical pressure that forces electricity to flow through a conductor. The size of the desired voltage depends on the size of the workload to be accomplished. In this illustration, we see a voltmeter measuring the volts from a test wire underneath the 46 kilovolt transmission lines. Current is the amount of electricity that flows through a conductor. The current is measured as amperes with an ammeter, as shown in this illustration. Current is sometimes compared to gallons of water per minute that flow through a water pipe or the current of a river. Ampere is a measure of the number of electrons flowing through a conductor per second. Current flows from the electrical utility power station throughout the countryside and returns to the substation by way of all conductors, including the metallic wires, the earth, the air, water, all animals, and man in its path. Electric and magnetic fields, EMF, radiate electricity from conductors. The electric and magnetic fields will vary in strength and direct correlation to voltage and current on the conductor. We can measure the strength of these fields with a Gauss meter. The plume of invisible lines surrounding the conductor are called the corona or crown. The intensity of electric fields is measured as volts per square meter. The magnetic field is measured as amperes per square meter. Inferior quality power is distortion of the normal 60 Hz waveform and causes pollution of the electric supply. Harmonics are frequencies greater than 60 Hz. Transients are short duration voltage spikes. Sags are voltages 5% less than normal or nominal. Swells are voltages 5% more than normal, and surges are short-term high-voltage transients. They all contribute to electrical pollution of the environment. Frequencies other than 60 Hz are called electrical noise. This is a graphic presentation of the voltage waveform depicting alternating current, AC, which is the electrical supply used in most of the world. From the left side, you will note that the voltage waveform starts at 0. The voltage reaches its positive peak at the upper red arrow and declines past 0 to a negative peak at the bottom red arrow and returns to 0. This is called 1 cycle or 1 hertz. The power company generator produces 60 cycles per second or 60 hertz. Harmonic signals are whole number multiples of the fundamental 60 hertz waveform, as in this illustration. The first harmonic is 60 hertz frequency. The second harmonic, 120 hertz, is shown with 2 peaks compared to the first harmonic. Then a third harmonic with 3 peaks, 180 hertz. A fourth harmonic with 4 peaks, 240 hertz, and a fifth harmonic with 5 peaks, 300 hertz of frequency or cycles per second. Harmonics can contribute to electrical pollution, causing electrical equipment to overheat or malfunction. A transient is a rapid voltage or current spike that occurs on the waveform. The spikes are usually of short duration, but may be very high voltage, as with a lightning strike. Opening and closing of switches and discharge of capacitors on power lines also produce transients. Linear loads have a uniform voltage, frequency, and current draw. They produce no distortion of the waveform except when a switch is turned on or off. Light bulbs, electric heaters, and motors with a constant charge are examples of linear loads. Prior to 1972, most electrical loads were linear. That is, they operated on normal, utility-supplied 60 hertz sine waves, alternating current. In the grounded Y distribution system used throughout North America, the unbalanced current should return to the substation via the metallic neutral conductor, the lowest line in the photo, provided the neutral is of sufficient size and designed to handle the types of current loads it will be required to carry. Since the early 1970s, we have seen a dramatic increase in the use of modern electronics, which are nonlinear loads. Nonlinear loads change alternating current to direct current. Direct current is current which travels in only one direction, as from a battery. Electronic devices change the frequency of AC current to speed up or slow down a process or signal. Variable speed drives switch mode electronic devices such as copy machines, MRI or magnetic radiation imaging, TV, cell phones, digital clocks, radios, some types of halogen fluorescent lighting ballast, and load switching capacitors on power lines, and hundreds of other electronic controls use nonlinear loads and contribute to electrical pollution. With nonlinear loads, the computer, TV, and so on, the neutral current can be 225% of the highest phase conductor. Notice that A, B, and C, the phase conductors, are carrying 20 amps each. The neutral, which is supposed to return the current to the substation, is 42 amps, or 225% of the highest phase conductor. With nonlinear loads, the majority of the neutral current flows uncontrolled over the earth and in the air. Now we have the earth and all the surrounding environment contaminated with dirty electric current.